Welcome, leaders and innovators. Today we are exploring a crucial distinction in the modern AI landscape. While generative AI is making headlines, traditional machine learning remains the powerhouse for driving specific, measurable business value. Let's get started by identifying exactly when and where machine learning adds irreplaceable value to your organization. Welcome to our first module. Let's start with the what and the why. What exactly is machine learning, and why does it matter to you as a business leader? Machine learning is a foundational branch of artificial intelligence. Unlike traditional software where human developers write explicit, rule-based code to solve a problem, machine learning enables computers to learn directly from your business data. Over time, these algorithms improve their performance automatically. Why is this critical? Because while generative AI is fantastic at creating net new content like emails or code, machine learning is your engine for numerical prediction, data classification, and clustering. How does it work? We feed the model historical data, and it learns to spot patterns applying human-like analytical judgment at a scale and speed that humans simply cannot match. In our deep dive today, we will focus on identifying the specific scenarios where applying machine learning provides the highest return on investment, ensuring you never use a hammer when you actually need a scalpel. Let's look at the flowchart on your screen, which visualizes the core mechanics of machine learning. At the top, we start with business data. This could be anything from decades of sales records to real-time sensor data from a factory floor. This data feeds into the machine learning algorithm. Unlike traditional systems, the next node shows that the algorithm actually learns patterns from this data autonomously. From this central learning node, the value branches out into three distinct, high-value outputs: predictive insights for forecasting, data classification for organizing information, and anomaly detection for spotting irregularities. This diagram strips away the complex mathematics and shows you the pure business flow. Data goes in, learning occurs, and actionable insights come out. To identify where machine learning adds value, we must understand the three foundational pillars of AI analytics: descriptive, predictive, and prescriptive. What do these mean? Descriptive AI focuses on the past and present. It handles search, classification, and summarization. It tells you what happened. Predictive AI looks to the future. It powers forecasting, anomaly detection, and risk scoring. It tells you what is likely to happen next. Prescriptive AI goes a step further, offering recommendations and optimization. It tells you what action you should take. Why is this framework so important? Because as a leader, your goal isn't to buy an algorithm. Your goal is to achieve faster insights and more efficient operations. How do you get there? By mapping your specific business challenge to the right pillar. Machine learning is the undisputed champion of the predictive and prescriptive pillars. Our deep dive takeaway is this: the strategic value of machine learning lies in its ability to permanently shift your organization's posture from reactive damage control to proactive, data-driven strategy. This visual breaks down the three pillars of AI. On the top row, we have descriptive AI, which answers the question, what happened, by summarizing and classifying data. In the middle, highlighted in green, is predictive AI. This answers what will happen through forecasting and risk scoring. On the bottom, also in green, is prescriptive AI, answering what should we do by providing recommendations and optimizations. The green highlighting indicates where traditional machine learning models shine the brightest. When you are sitting in a boardroom trying to solve a supply chain issue, you can use this diagram to quickly identify whether you need a descriptive summary of yesterday's failures or a predictive machine learning model to forecast tomorrow's bottlenecks. A critical skill for any AI transformation leader is knowing the difference between generative AI and traditional machine learning. What is the difference? Generative AI is a creator. It generates text, code, and images. Machine learning is an analyzer. It predicts, classifies, and clusters. For the basics, look at your daily tasks. Drafting a marketing email or summarizing a 50-page PDF, that is a generative AI use case. But predicting which of your customers will cancel their subscription next month, or detecting a fraudulent credit card swipe in milliseconds, that is strictly a machine learning use case. Why must we separate them? Because applying a creative generative model to a strict mathematical forecasting problem is highly inefficient and prone to hallucination. How do they differ under the hood? ML models thrive on structured, numerical data to find correlations. The deep dive here is synergy. The most sophisticated enterprises combine them. They use machine learning to predict an insight, and then use generative AI to automatically draft the report explaining that insight to stakeholders. Let's walk through this decision tree. It is a highly practical tool for your organization. At the top, we start with a business problem. You immediately hit a decision gate asking for your goal. If your goal is to create content, you follow the path to the left, arriving at generative AI. This branches down into tasks like drafting reports and summarizing documents. However, if your goal is to analyze and predict, you follow the path to the right, arriving at machine learning. This path leads to high-value tasks like predicting customer churn, detecting fraud, and personalizing product suggestions. By applying this simple visual framework, you ensure that your engineering teams and your business stakeholders are perfectly aligned on which technology stack is required to solve the problem at hand. Now, let's explore specific scenarios where machine learning adds massive value, starting with predictive analytics. What is predictive analytics? It is the practice of using historical data to mathematically forecast future events, such as sales volume, supply chain demand, or financial risks. The basics are simple. You feed an ML model years of past behavior, and it identifies complex, hidden trends that a human analyst using a spreadsheet would never see. Why is this so valuable? Because it allows leaders to manage inventory proactively, forecast revenue with high confidence, and mitigate risks before they materialize. How is it executed? The algorithm processes structured data from your CRM or ERP systems and outputs a definitive probability score or a projected future value. Our deep dive highlights the financial impact. In industrial settings, predictive ML models are used to monitor machine telemetry. By predicting an equipment failure days before it happens, the business can perform preventative maintenance, saving millions of dollars in unplanned factory downtime. This sequence diagram illustrates the life cycle of predictive analytics. On the left, we have our historical CRM and ERP data. In the first two steps, this rich data source feeds 5 years of sales history, alongside seasonal trends and pricing variations, directly into the ML predictive model. The model then works internally, identifying hidden correlations across millions of data points. Once the analysis is complete, the model sends a business insight to the output node specifically, a highly accurate forecast for Q4 demand. The final step shows the ultimate business value. The system automatically optimizes supply chain orders based on that forecast. It is a seamless flow from raw historical data to future-proofing your business operations. Our second high-value scenario is personalization and clustering. What does this entail? It means using machine learning to group customers who share similar traits, allowing you to tailor product suggestions and experiences to individual behaviors. At a basic level, the ML algorithms analyze vast amounts of customer data, purchase histories, browsing habits, and demographics to segment your audience automatically and dynamically. Why do the world's top retailers invest heavily here? Because hyper-personalization dramatically drives up conversion rates, deepens customer loyalty, and maximizes lifetime value. How does the machine do this? It often uses unsupervised learning techniques, like clustering. This means you don't even have to define the categories yourself. The algorithm finds the natural, hidden groupings in the data. Diving deeper, this capability enables what we call segment of one marketing. Instead of blasting a generic email to 1 million people, the ML model personalizes product suggestions for each individual user based on their real-time micro-behaviors, resulting in a vastly superior customer experience. Take a look at this flowchart mapping out the clustering process. We begin at the top with a massive pool of raw customer data. This unstructured mix flows into the ML clustering algorithm. The algorithm works its magic and dynamically splits the audience into distinct behavioral nodes. For example, it identifies a high-value segment, a churn risk segment, and a discount-driven segment. Notice how each distinct segment maps directly to a specific, optimized business action at the bottom. The high-value users receive upsell recommendations, the at-risk users trigger retention campaigns, and the discount shoppers get targeted promotions. This diagram proves that ML doesn't just organize your data, it directly prescribes the most profitable marketing strategy for every single customer. The third highly impactful scenario is automation and anomaly detection. What is an anomaly? It is a rare event, item, or observation that differs significantly from the vast majority of your data, thereby raising suspicion. The basics of this ML approach involve training a model to deeply understand what normal operations look like. Once it knows the baseline, it can instantly flag any deviation. Why is this absolutely crucial for modern enterprise? Because it is the backbone of credit card fraud detection, automated quality control on manufacturing assembly lines, and identifying cyber threats in your IT network. How is it implemented? These ML models are deployed to process millions of transactions or sensor readings per second, instantly scoring each one for anomalous attributes. Our deep dive reveals why this is a massive upgrade over legacy systems. Traditional, rules-based systems rely on if-then statements and completely miss new, evolving types of fraud. Machine learning models are dynamic. They adapt and learn new attack vectors in real time, providing an incredibly robust layer of automated security and quality control. Let's trace the path of anomaly detection using this real-time flow diagram. On the far left, a continuous stream of real-time transactions hits the ML anomaly model. The model scores the transaction in milliseconds and hits a decision gate. Is the anomaly score greater than 95%? If the answer is no, the path continues smoothly to approved transaction. However, if the score exceeds the threshold, the path diverts to flag as fraud. This immediately triggers two automated business actions: an automated account freeze to stop the financial bleed, and an alert to the security team for human review. This visual beautifully captures the essence of machine learning automation, the ability to make high-stakes, highly accurate decisions at a speed that protects the business without interrupting the legitimate customer experience. To successfully leverage machine learning, leaders must understand that it is not a plug-and-play product. It is a life cycle. What is the machine learning life cycle? It is the structured, highly iterative process required to build, deploy, and securely maintain a custom ML model. The basics involve distinct phases: defining the business problem, preparing clean data, training the model, evaluating its performance, and finally, deployment. Why is understanding this cycle critical? Because ML models degrade over time. As market conditions shift and new data patterns emerge, models experience what we call drift, losing their accuracy. How do we execute this? It is a team effort. Business leaders define the exact KPIs, data engineers source and clean the information, and data scientists train the algorithms. Our deep dive is a warning for IT leaders. Unlike traditional software, an ML model is never finished. To ensure it continues to add business value, it requires continuous monitoring, retraining, and governance, a practice known as MLOps. Planning for this life cycle is the difference between a successful AI deployment and a failed experiment. Take a look at this diagram mapping the machine learning lifecycle. We start at the top node, define business goal. This is where you, the leader, step in to align AI with strategy. The flow moves sequentially through data preparation, model training, and evaluation and testing. Once the model proves its accuracy, it hits the final node, deployment. But notice the most important part of this diagram, the dotted arrow, looping all the way from deployment back to data preparation. This represents the monitor and retrain phase. It visually reinforces the concept that machine learning is a continuous, iterative loop. Your business is not static, your data is not static, and therefore, your machine learning models must continuously adapt to sustain their value. Let's bring all of this together into a real-time, highly impactful use case: the hybrid AI solution. What is this? It is the strategic combination of machine learning and generative AI to solve an end-to-end business challenge. The basics: imagine a telecom company suffering from high customer cancellation rates. First, they deploy a machine learning model to analyze usage data and accurately predict exactly which customers are at risk of churning. Then, they hand those ML predictions over to a generative AI model, which instantly drafts a highly personalized retention email offering a specific discount tailored to that user's behavior. Why is this the gold standard? Because ML identifies the hidden mathematical problem, while Gen AI scales the creative communication required to solve it. How is this orchestrated? Through a seamless pipeline where Azure Machine Learning scores the database and Azure OpenAI generates the text. The final deep dive for you as a leader is the build versus buy strategy. If your churn prediction is standard, use a pre-built Azure AI model. But if your data is highly proprietary or regulated, invest the resources to build a custom ML model. By combining these technologies appropriately, you unlock maximum business value. Our final sequence diagram illustrates this powerful hybrid AI pipeline in action. It starts with the customer DB passing usage data to the custom ML model. The ML model does the heavy analytical lifting, identifying a hidden pattern and sending an alert to the generative AI engine, flagging user as a 90% churn risk due to high pricing. Armed with this precise, predicted context, the generative AI engine takes over. It autonomously drafts and sends a personalized 20% discount email to the at-risk customer. The final step is the business outcome. The customer renews their contract and ROI is achieved. This visual perfectly summarizes our training. Machine learning finds the invisible targets and generative AI pulls the trigger, creating a fully automated, value-generating enterprise architecture.